So over here on the left, I have a kind of a fill in the blank for what we talked about last week. For a parabola. This is something that's always covered in Math 103, Algebra 2, and it applies to basically everything you would ever want to see in terms of a parabola, a vertex form of a parabola. And we're going to apply it to every kind of graph we ever are going to see. We're going to make this a little bit bigger. The vertex form that I talked about last week was f of x is equal to a coefficient a times parentheses x minus some number h squared and then plus a k. Now in the book, they don't use h and k, they use c and d. And that doesn't necessarily matter much. Verifying. Well, actually, they use C regardless. They're using C everywhere, which in that case can be kind of confusing. So that is nice that I'm using different letters. Okay. The A out in front controls a couple of things about any kind of graph you're ever going to graph, no matter what. A controls something about the graph. It's also going to be covered in today's notes, but with respect to what you know about positive x squared that goes like this versus negative x squared that will look like this. If the value of the coefficient is positive, then what do we know about the parabola? It's going to go up. It's going to go up. If it's a positive something squared, a positive, so you see a basically 1 times x squared, 2 times x squared, 1/3 times x squared, any positive number, it's going to open up. Opens up like a cup. Or when you're positive, you're happy, you're smiling. I don't know what it takes for people to remember it, but positive means up. If it's less than 0, negative numbers, -2, something squared, -1/2, something squared, negative, and then you square. If you have, y equals a negative and then x squared, that negative is not being squared, only the x is. So if I plug in 3, y equals negative and then 3 squared, the answer would be -9. So the y values are going down instead of up. If it's a negative number, it's going to open down. Down like a frown, because when you're negative, you're unhappy. And that means it's a reflection across the x-axis. It reflects the parabola across the x-axis. You're going to see how that all plays out with all the graphs that we're going to do today. This is also going to play out today. But here's what we know in terms of parabolas. Our basic parent curve, just 1 times x squared. F of x is equal to x squared. A 1, positive 1, it opens up. But we don't care if it's positive or negative. It's just because it could be a positive 1. We take the absolute value of positive 1, we get 1. It could be a -1 in front of the x squared. So A is -1, but this says you take the absolute value of that -1, you get a positive 1. If the absolute value of A is a positive 1, if it equals 1. We call that our normal graph. That's our normal width. The parabola has normal width. Because you got to have something to compare to if it's going to have it's called a non-rigid transformation. And we'll get to what that means at the end of 1.5, which is sooner than later. If you have a 1 times x squared, something's going to make it narrower, something's going to make it wider, but you got to have something to compare. When does it stop being wider? When does it start being narrower? Where's that basic, simple parent curve? At 1x squared. 1x squared would be your normal width. If the absolute value of the a in front of your square, if that a is greater than a 1, if it's greater than a 1, so it could be a 2 times an x squared. It could be a 3 times an x squared, 5 times an x squared. It could be negative 2 times x squared, because again, it says absolute value. So if I take the absolute value of -2, I get +2, and that's bigger than a 1. Remember, fractions can be bigger than 1. If this was -5/3. So a is a -5/3, absolute value of -5/3, +5/3. 5/3 is 1 2/3. 1 2/3 bigger than 1. If it's bigger than a 1, then that parabola is much narrower than your normal parabola. It's a lot narrower. It's going up faster than 1x squared does. So it's narrow compared to the 1x squared. We don't want to call it thinner or skinny because we don't want, to change it. And then you have equal to 1, greater than 1. There's only one thing left it could be. What's that? Less than 1. Equal, greater than, or less than 1. So less than 1. If it's less than 1, and that doesn't mean it has to be negative, it just means it could be 1/2 x squared. The absolute value of 1/2 is +1/2. It could be a -1/2. Absolute value is still a +1/2. It cannot be 0, because if it's 0, 0 times whatever's in here is just going to be 0. So a could never be 0 in the first place. But if it's a fraction, except for 0, between -1 and 1, if this is normal and that's narrow, then this one is going to be wider than your 1x squared. It's wider than your normal 1x squared. Because if it's 1/2 all of your old y values, it's going up half as fast as your old y values. Talked and showed a little bit. We talked about the h. If you mess around with your x's in here, that h is inside, has to be, if you're going to find an h, it would have to be inside of parentheses with your x. H is messing around with your x. Okay? H is messing around with your x. There's always, no, I don't want to get ahead of myself. So if you're looking for it, you got to look for where your x is, and that's where h might be. And they have to be in a parentheses together. You're going to catch them together. Your x and somebody new. H is the horizontal shift. The last class actually laughed at that. So forget you. I know I give up every week. It's the horizontal shift. You give up twice a week. It's the horizontal shift of the graph. It's going to slide that graph left and right. Inside that parenthesis, x minus the h. There's always a blank, blank, or in blank. There's always a blank, in blank, inside the blank. A negative. In front, I should have said in front of the H. Slip that in here. In front of the H. Inside of the parentheses. Inside of the parentheses. Always a built-in negative. Always. So it's always x minus h. So when you identify the h, it's going to be the opposite. I think that's what happened. I wrote it. I was going through my head. Oh, I know what. The opposite sign or opposite sign for the H in front. You see +3, H is a -3. You see -5, H is a +5, because that negative is always there. K is the what shift? The vertical shift. K comes after the square. After the square. So if you saw y equals 3 times x squared plus 4, that is not in a parentheses. In fact, you don't have a parentheses at all. 3 is the coefficient, so A is a +3. There's no parentheses at all. So inside the parentheses, H would have been 0. The only way to have X by itself is because it was X minus 0, and then it got squared. X minus 0 is just X, and X squared is just X squared. This comes after the square, after the square. So K is a +4. K is the vertical shift. It's going to move the graph up and down. Since K has a what in front? A plus. You will always keep the sign. That's what I mean. It is always the opposite side. That's why there's that. Fewer lines, but it's always the opposite. Together, when you find the H and the K, that is called the vertex. That's where the vertex is for the parabola. It's the most important point you got to plot and graph. It's like finding the y-intercept when you want to graph a line. You find the y-intercept and you count the slope. You find the vertex, and that's where you know your parabola is going to be. And then does it open up or down? And then you plot a couple of more numbers so you draw it accurate. So this all ties in as we go right over here. So here is our parent curves that we talked about, looked at last week. The linear functions, y equals x, f of x equals just 1 times x. Absolute value are v-shaped. Square roots kind of look like the radical sign itself, but as you can see, the square roots, okay, square root function, they have a limited domain. You can't have a negative inside of that radical. That's why it only goes this way, and it's only above. Parabolas or quadratic functions, parabolic functions, a cubic function next to the third. And then the rational functions, vertical asymptote at 0, or wherever the denominator ends up equaling 0. 1 over 0 is undefined. That's why you don't have anything here at 0. And you have this look to the left and to the right. And this is where we actually wrapped up. So what I did was, I just basically cut and paste that picture of the parent functions. And where we left off last week, we actually did the horizontal shift. Something's going to shift C units or H units to the right. So look what you see. You see X minus. You see minus, but it's going to go right. You're going to go in the opposite direction. It's X minus 2. You're going to go 2 to the right. You see X minus 5. You're going to go 5 to the right because you're going to do the opposite sign. It's going to go to the left. If you see X plus, you're going to do the opposite sign. That's that X minus H. Okay? F of X minus the H. So inside the parentheses, you either have subtracted a positive, that's why it's going to the right, or you subtracted a negative, that's why it's going to the left. If you add a number, this is the plus K. If you add a number to the function, it's going to shift it up. If you subtract a number from the function, it's going to shift it down. That's the plus K or minus K. On the K, it has a keep the sign. It's always a plus K. So you see plus 3, it's going up 3. You see minus 2, it's going to drop 2. Keep the sign on the K's. And then here's how we reflect this. It's going to reflect across the x-axis. So instead of going up like a parabola, a negative x squared is going to flip down because of the negative in front. All those x squareds that come out positive, if you put a negative in front of them, they're all negative answers now. So they're down below. No matter what the graph is. No matter what graph you're doing, if you put a negative in front of the function, then all the y's that you used to have are now going to change signs. If the y's that you had were positive, they're now going to be negative. If you had negative signs before, they're now going to flip up and they're going to be positives. Okay. For instance, and I use this example to scare the heck out of my Math 103 students. And Lewis, you got to give me a shout out if I don't move the camera, okay? I gave them a little bit of a sneak heart attack. I told them that in trigonometry, we graph, f of x is equal to the sine of x. And when you graph the sine of x, it's a wave, it's periodic, it goes on forever. From 0, does this, and it continues to go up and down forever and ever. It goes up to 1, down to -1. That's 2 pi radians, that's 1 pi radians, and so on. But if you put a negative up here, that's +1, down below goes down to -1. If you put a negative in front of the sign, then all of those positive answers now are going to have a negative once you take the sign off. And all of these negatives are now going to have a negative times a negative. They're all going to be positive. Everything that's up here will flip down below. And everything that's down here will be flipped up above. That's what a negative does for gravity. It's a reflection across the x-axis. No matter what we're graphing, absolute values, square roots, sine functions, cosine, any kind of function. You change the sign on the function, you're going to flip it vertically across the x-axis. If you change the sign inside on the x, that's when you get a reflection across the y-axis. So reflection across the x, you change the sign out in front of the function. If you change the sign on the x on the inside, you're going to flip it from right over to left, left over to right, across the y-axis. Okay? For instance, the parent function of square root. The square root of x. Now, we know we cannot plug negative numbers in here. If you try to go, let x equal negative 4. F of -4, square root inside -4. That is not a real number. We can't grab it. So we can only pick numbers that are non-negative. So the domain that we can use has to be greater than or equal to 0. So the first thing you would pick would be 0. Square root of 0 is 0. Then the next nice perfect square is 1. Square root of 1 is 1. The next nice perfect square that you can take would be the square root of 4. So when we plug in 4, we get 2. The next nice perfect square is the square root of 9. So f of 9. Square root of 9 gives us 3. So when 9 goes in, we get 3. Now the x's are increasing by, it's not even the same amount, but the y's are going 1 up at a time. 0, then 1, then 2, then this is a 3. So the next nice y we should get would be a 4, and we're going to get a 4 when we plug in 16. F of 16 is the square root of 16, and that's why we get 4. 16 will give us 4. And that's why the square root takes this shape. Okay. Always. It'll keep on going forever. Forever. X will continue being large, huge quantities, and you're going to get another square root that'll happen. Square root of 100. At 100, this thing will finally be up here to 10. Okay. If we did this, f of x equals negative, and then square root x, then all those positive answers that you just got, they would be down here instead. Oops. They would reflect down here. Reflection across the x-axis, because I put a negative in front of the function. But what happens if I put the negative on the inside in front of the x? So f of x is the square root of negative x. try 4. Last time I plugged in 4, that's what we did, started with, try 4. F of 4 would be the square root. This negative is part of what you're supposed to do. So that negative is already inside. And only thing you're doing is you're replacing the x with a 4. So f of 4, that negative is here, and then you put a 4 into the x. And now you're trying to take the square root of negative. You can't plug positive 4 into this function. You cannot plug positive 4 into this one, because you got a negative in front of the x. A negative in front of the x is going to flip everything that you got going this way. It's going to flip it and go this way. Your x's have to be greater than or equal to 0, right? The inside. Let's look at the domain for a second. Let's talk about this. Remember, you had to do something about domain and range in the last, section, last quiz, whatever. I didn't ask you g of x, square root of x. But we talked about it. Domain of a square root of an even root cannot be negative on the inside. If it can't be negative, it can be 0 or positive. So whatever's in here, you take that and you say the domain has to be, those x's have to be greater than or equal to a 0. That's my domain. So if it was g of x equals x minus 4, then we would say, all right, this x minus 4 has to be greater than or equal to a 0. What's inside has to be bigger than a 0. Can't be a negative. Then you add 4. And now we know that if we're going to pick an x, we can only choose x's that are greater than or equal to 4. That's the domain. If you pick 3 minus 4, -1, you can't use 3. The domain starts at 4, equal to 4, and only goes to the right. So now, when you got to deal with this domain. So h of x is equal to the square root of -x. Put a negative in there. Same process. Inside of the radical, inside this negative, that whole inside, -x, must be greater than or equal to 0. Because you can't take the square root of a negative. But here's what you got to make sure you remember. I could give a rat's behind or a rat's ass with -x. When I'm trying to figure out the domain, I'm not trying to figure out -x. I don't care what x minus 4 is. I want to know what x's can do. So I got to solve for the x. I don't care what -x can be. I want to know what x is allowed to be. Well, what do I do to solve that -x greater than or equal to 0? What do I got to do? Really, you don't know how to solve a -1 times x problem? Divide by negative. Divide by -1. Honestly, everybody, if you're going to do well, you've got to communicate with me. If you don't want to be here, I can't make you stay. But if you are going to be here. Be a part of what we're doing. Stay off your phones. Okay. I'm not a dentist. I'm not going to pull your teeth, but it feels like I'm pulling teeth. I'm asking a question like -x solved, divide by -1. What has to happen if I have an inequality and I'm dividing by a negative? That is absolutely true. But what else is going to happen because it's an inequality? You gotta flip the inequality. If you multiply or divide by a negative and it's an inequality, now flip that inequality. Always. If you multiply or divide by positive, you'll flip. Multiply by a negative, you gotta flip the inequality. I mean, think about it. Is it -5 less than +3? Yeah. If I multiply both sides by +2, multiply by +2. This is -10. That's +6. -10 is still less than. It's still less than +6. But I multiplied by positive. If I change that to -2 and -2. -2 times -5 is now +10 on this side. -2 times 3 is now -6 on the right side. Which one is bigger, 10 or the -6? 10. 10 is greater than the -6. The inequality that used to be less than is now greater than because I multiplied by a negative. Division is just multiplying by a reciprocal, so it works for division as well. If you multiply or divide by a negative, we must flip this inequality. So when I solve for x, this is now +x. This is 0 divided by -1, 0. But because I divided by a negative, this greater than or equal to is now less than. My domain must be less than 0 or equal to 0. So I can only plug in numbers to the left of 0 because of that negative in front. And that's what the reflection is going to do. It's going to reflect it across the y-axis. The reason why I'm doing this, everybody, is because you don't need to plug in a whole bunch of numbers. You need to know all the little pieces and what they're doing for you. If you can read the equation, you know exactly where to put it and exactly what it's going to do, and you don't have to plug in anything, except maybe 1 or 2 points, just to get some accuracy. So that when you plot it, it actually looks like you did something. Okay? I can still plug in 0. Square root of -0 is just square root of 0, which is 0. So it's still here. But I have to stay to the left, so f of -1 would be the square root of this negative, and then I'm replacing the x with a -1. So it turns out being the square root of +1. And so that gives me 1. And it's over here. The next perfect square is going to be 4. So f of -4 would be the square root of a negative, and then your -4 goes in. So that f of -4 is really the square root of 4, and you get 2. The next perfect square would happen at 9. So -9 would give me 3. -16 would give me 4. And if I had to actually do this, f of x is equal to negative square root of 3 minus x plus 2. A square root x minus h, and then a plus k is your equation for a square root with all the trimmings. Okay, that's your combo pizza versus your parent function. The parent function is that cheese pizza of just square root x. So what I might want to do is rewrite that so everything lines up. So put it over here. I want to know what the A, the H, and the K's are. I want to know if there's any, horizontal or vertical flips. So for a square root, a square root, and then x inside minus h, and then a plus k. And right now you're looking at f of x, negative square root, you have 3 minus x, and then a plus 2. So before you start writing things down, x minus h, x should be first, h should be second. So this is f of x equal to negative. Inside here would be negative x, and that's a positive 3. When I put the x in front of the h, negative x and then a positive 3. And then my plus 2. So the a that's in front, a is a negative 1, so that means it's going to go down instead of up. Now, the square root that goes up looks like that when a is positive. So the one that goes down would go like this. It goes down. Okay. Now you have to ask yourself, is it a positive x or a negative x? Well, it looks like we got ourselves a negative x in there. So it is going to take this that is supposed to open down, and it's going to make sure that we go in that direction instead because of the negative x that's involved. Okay? So it is going to go down instead of up, and it's got to go to the left instead of to the right. Inside, x minus the h. So what would h have to equal? A negative 3, opposite sign. And then k, we keep the sign, that's a positive 2. Now, parabolas don't have a vertex. Vertex means you reach the lowest point, a minimum, or an upper point, which is a maximum. They don't have a vertex. So I just call this the initial point or the starting point, first point. So that first point is the HK, and that's going to be at negative 3, positive 2. So at negative 3, positive 2, negative 3, and then up 2, I know that this thing is supposed to go down. I messed it up, because I know what I should have done. All right. I tricked myself because I didn't give myself this piece of information. So right here, f of x across the y-axis, f of the negative x. I got two terms though. I got two terms. And I should have known this because of trig. Thumbs up. This. Right now, I do still have x negative x and then a plus 3. What I need, because there's two terms, it's a negative in front of that whole inside of the radical. You have to factor out whatever is actually in front of your transition, your translation. So if you factor out a -1, negative x divided by -1 is positive x. Positive 3 divided by -1 is -3. That's what we're doing the opposite of. We're doing the opposite of x inside, the opposite of the whole thing. Not just the x, but the opposite of the whole inside of the radical. So that's why you have to separate the negative from the two terms. So now we know that there's a flip this way. H is a positive 3 inside that parentheses. K is a positive 2 on the outside. So that first point is at 3, 2. Over here. It is still going to go down and to the left that way. Still going to go that way. But we got to factor out the negative if there's two terms. If it's a positive x, you won't have to do anything. When a negative is involved, you're going to have to do something.
So x is still a negative x, right?
Yeah, because it's fixed. You distribute the negative back in, you get negative x. And then a plus 3, the original problem. Okay, so I'm going to label this. This is at 3, 2, the first point. You need to plot just more than the first point. Just drawing that is not good enough. Give yourself just a few ordered pairs to plot and label. If that's my vertex, if that's my first point, I'm going to go 1 to the left because that's my domain. I would plug in 2. You could do it in the one that you made here or in the original. So I'm going to find some room here to do my original. I'm not sure to stay on camera. So if I plug in positive 2, it's negative square root 3 minus 2 and then plus 2. So f of 2 is negative square root of 1 plus 2. So f of 2 is negative 1 plus 2, which is 1. Remember what we just started with? It's supposed to start here and go 1 to the left or go down to the left. When I plugged in 2, I better not get something up here. It's got to be down below going to the left. And I got 2 goes in, 1 come out. 2, 1. So now I know it's going to go through that point. Okay. You got to be choosy. You don't want to plot square root of 2. Coming up with the square root of 2 is 1.414. You don't want to plot that. You don't want to plot square root of 3, 1.732. You don't want to plot that. You want to plot nice numbers that come out of your square root. You want to plot when you get, square root of 1, that's a 1. Square root of 4, that's a nice 2. You want to get the square root of 9, because that's a nice 3. Square root of 16, that's a nice 4. You want to get some perfect squares inside. So when you take the square root, you get nice numbers. Remember, 3 minus x. When I plugged in 2, 3 minus 2 gave me the 1. Now I want to get 4, because I took care of the 1. 3 minus 2 equals 1. Now I want that 3 minus x to equal a 4 on the inside. So what does x need to be? -1. Subtract 3. Negative x is equal to 1 divided by -1. And x would have to be a -1. F of -1 is negative square root 3 minus -1 and then plus 2. Negative square root 3 plus 1 plus 2. Negative square root of 4 plus 2. -2 plus 2. 0. When -1 goes in, we get 0. When -1 goes in, we get 0. We want one more nice perfect square. So we want to get a 9. 3 minus x, we want to get a 9. So what should we plug in for x? -6. Think about it. It's going to be 3 minus something to be 9. You know we're plugging in negative numbers because we're going to the left. What makes a 9? 3 plus 6. So if a -6 goes in, we'll get a 9. So if we plug in -6, we're going to get a square root 9. And so it would be f of -6 would give us a negative square root 9. And then plus 2. So f of -6 would give us a -3 plus 2. And f of -6 would give us a -1. And then think about what a square root does. As x increases by an unknown amount sometimes, the y's are decreasing by 2 to 1 to 0 to -1. Let's go in that direction. But we found A, we found, is it a negative x because there's a horizontal shift, horizontal flip? I made a mistake with the h, but we corrected it. And here's how I know I would have really messed this up. I plug in, and I thought it was going to be -3. Then I would have gone over here and I plug in -3. 3 minus -3 is 3 plus 3. Square root 6, I'm supposed to get nice numbers. That first number I plug in should be nice. Technically, it should be 0. That's why the horizontal shift is exactly the h. You should get a 0 when you plug it in. And since I did not get 0 when I plugged it in, I knew that I made a mistake because I didn't factor out that number. Non-rigid transformations. Last piece of this. We've talked about A is a horizontal, or sorry, A is a flip across the horizontal line, x or y equals 0 across the x-axis. Non-rigid. H is a rigid or transformation because the graph does not change at all. You just move it left and right. K moves it up and down. It doesn't change at all. It just moves it up and down. The vertical flip and the horizontal flip, they don't change size of the parabola or the square root or any of the parent graphs that we have. It's not changing what it looks like. It's just flipping it and it maintains the exact same curve. So those are rigid transformations. A non-rigid transformation is something that is going to change the width, make it narrow, make it wider. Okay. Horizontal shifts, vertical shifts, reflections are called rigid transformations because the shape of the graph is unchanged. These transformations change only the position of the graph in the coordinate plane. Non-rigid transformations are those that cause a distortion. Okay, 1 times x squared, 1/2 x squared, 2 times x squared. Okay. A change in the shape of the original graph. For instance, non-rigid transformations of y equals f of x is represented by some number c, or I'm using a. Because they're using c for everything. Which c are you talking about? So some number out in front times the function. Times the function. Where a transformation is a vertical stretch, so it's stretching it this way, if it's bigger than a 1. Now I say absolute value has got to be bigger than 1, so because it could be flipping upside down. Because right now, if it's a -2, then -2 is not greater than 1. People get confused by that. So the positive and negative just means up or down. Is it actually bigger than a 1 after you look at the absolute value? That would determine if it's going to be a vertical stretch or a vertical shrink. Shrinking means wider. Stretch means it's going to be more narrow. Okay. Another non-rigid transformation is represented by when you multiply inside c times x. Something times the x, where the transformation is a horizontal shrink. Again, when we do a trigonometry class, the normal period for a sine wave is 0 to 2 pi. Well, we can change the period and make it 1 pi. So instead of 1 oscillation between 0 and 2 pi, we can make it 2 oscillations between 0 and 2 pi. We can shrink it horizontally. We can stretch it vertically. We can shift it up, we can shift it down, shift it left, shift it right. All because of the A, the H, the K. And there's in trig, it's a B times the X in front. Okay. Transformation of the horizontal shrink, if it's greater than 1. Horizontal stretch, if it's between 0 and 1. It's less than absolute value. And that just means it's stretched this way, and that's kind of like the backwards of the vertical, because it takes longer to achieve that many numbers. If it's like 1/2 an x, when you plug in 4, 1/2 of 4, it's going to be like 2. It's doing whatever 2 did. So it's happening half as fast on the x-axis as it normally would. So it's going to get stretched out this way. If it's bigger than 1, then it's happening quicker. So you're going to get those numbers a lot quicker than you would. When you plug in 2, it's going to pretend like it's a 4. It's going to do what 4 would do. So it's going to happen quicker. And your y value is going to happen a lot faster. So let's take a look at the home. All right, 1, 2. Name 3 types of rigid transformations. We already talked about. Actually, just gave you the answer. Match the rigid transformation of y equals f of x with the correct representation, where they're using C again. So if we add something after the function, is that going to be left and right, up or down? If it's plus, add, up. So that would be a vertical shift up. So A is II. And then the function minus a constant means we're going to shift it down. So that would be IV. All right, have we paid attention? F of x minus a c. Is it a horizontal shift c to the left or horizontal shift c to the right? We're going to the right. You see minus? Then you got to do the opposite direction when it's inside with the x. That's a built-in negative, so C is actually a positive. It's shifting to the right, C units. Okay? And that goes to 15. Technical, 15 and 17. Okay, let's do 17. 17. So f of x is 1 over x, g of x is 1 over x and then minus 2, and then h of x is 1 over x minus 1, and then a plus 2. So the parent function 1 over x. 1 over x has a vertical asymptote. You can't plug in 0. So at 0, we have this vertical. I can change that. This vertical asymptote. That's like that wall. First thing I want to find is that undefined value. X cannot be 0. There's my asymptote. Then the parent function. If I plug in positive 1, I get 1, 1, 1. If you plug in positive 2, you get 1/2. Positive 3 is 1/3. Positive 4 is 1/4, 1 over 4. If you plug in 1/2, if x is 1/2, 1 over 1/2 is 2. If you plug in 1/3, you get 3. If you plug in 1/4, you get 4. So that's why the graph does this in the parent function. It gets infinitely close to the wall, to that vertical asymptote, but it can never cross it or touch it. And then as you get further along the x-axis, 1 over x is going to get infinitely close to the x-axis, but it's never going to touch it or cross it. So that's what it's doing on the right-hand side. And when you plug in negative x's on the left-hand side of 0, we're just going to get these values, but they're going to be negative. When you plug in -1, 1 over -1 is -1. When you plug in -2, you get -1/2. -3 is -1/3, and so on. -1/2 is going to give you -2. -1/3 will give you -3. And so it'll go like this. So that's what the f of x function looks like. And then when you do g, 1 over x, so it's that graph, and then we have a -2. Is that an h or a k or an a, or is it flip left or right or up or down? What is it? So it's messing with the x's. Because if it's a shift to the left, we have to mess with x's left and right. So that's a k. Because here's my function, and then after the function, we are taking 2 away. After the function, you're taking 2 away. So that's the plus k. If you want to mess with the x's, that's a left and right. So it has to be down under the square root, under the fraction with your x. Remember, H is a horrible person. He's messing around with your x. Or he's a horrible girl, messing around with your ex, or whatever. Whoever your other significant other is, H is messing with him. Don't catch him in that parenthesis. All of these are going to get shifted down too. The most important one that you found was 1, 1, shifted down 2. Down 1, down 2. It's here now. It's not moving left or right, so the vertical asymptote is still at 0. But what else shifted was this horizontal asymptote. If you notice, it does not touch the x-axis. It doesn't cross the x-axis, just like it doesn't touch the y or cross the y. This x-axis is basically a horizontal asymptote. And it separates the above from below. If this point gets shifted down 2, then the horizontal asymptote is also going to have to be shifted down 2. Because now all of these are going to be 2 below it. You know, what used to be here at 2 is now going to be here 2 lower, it's going to be here at 0. What used to be at 3 is now going to be at 1. What used to be at 4 is now going to be at 2. So what used to be at almost 0 is now going to be down below and almost be at -2. And so that asymptote is going to go like this. And it's going forever really close to -2. And up here, is doing this, going up. And the same thing here, except this is going to be coming from below. This asymptote on this side is going to be here -2 as well. When you plugged in -1, we got -1, but we're going to drop it down 2, which is now at -3. And so from this side, it's going to go like this. And it's going to go heading close to 0 like this. Not right on top of the other one, but I don't have a big enough grid to actually make it more accurate. Now here, it's everything the last one was, except down below, that x is now x minus a 1. So now, down below, underneath the bed, underneath the fraction, there with your x minus 1. So who's messing with the x? +1 or -1? +1. I mean, that H is, I mean, they're a horrible person. It's always the negative of them. I mean, they're two things. You see a negative, H is a positive. You see a positive, they're lying. H is a negative. H is a +1, K is equal to a +2. So that means everything has to shift 1 to the right and 1 down. When you're doing the rational functions, and that's what this is, a rational function, fractions, the best thing to do is to shift the asymptotes. That asymptote here is at 0, 0. When it was just -2, we dropped the asymptote down to 2 units. It was down here at 0, -2. The x's didn't shift, but the y shifted down too. Now you got to shift the x's 1 to the right and then down 2. So now the asymptote is going to be here. And it's going to be here again. So if I can't plug in 1, let's plug in the very first number that's next to the 1, 2 to the right. Okay, instead of 1 to the right, go 2 to the right. So h of 2 would be 1 over 2 minus 1. And then plus, oh my God, I was assuming, and I just made an ass out of it. When you assume, you make an ass out of you and me, but I only made it out of you. Oh.
I did do a double take. I was like, "We didn't say that."
It's a plus 2, not a minus 2, so it's actually. One of these days, you will be using phrases that nobody will get. Those are not numbers. So 1 over 1 plus 2 is 3. So when 2 goes in, we get 3. So when 2 goes in, it's right here. And look at all of our work. The intersection of the asymptotes was at 0, 0. It was right here in the next corner at -1, -1, 1, 1. We moved it down 2. The first point was directly diagonal, right here, 1, -1, right here at -1, -3. Because we moved it 2 down. We moved it 2 up and 1 to the right. So here's the intersection of the asymptotes. Diagonal is 2, 3, right there. And the other one I bet is going to be right there. So it's going to pop right here. I love when they say in the same coordinate plane because it looks so good. But you get to see how all the shifts play out with each other. Okay. Now 17. $19. Okay, use the graph of F to sketch each graph. To print an enlarged copy of the graph, you go to mathgraph.com and you can print out that graph and then just move the dots. And that's all we're doing is going to move the dots. The first A, it's the picture of this function. This is a picture of f of x. The new y values are all of these old ones, except you now add 2, a vertical shift of 2 units. So when 0 goes in, we usually get -1, add 2. It's now here a positive 1. When 1 goes in, we get 0. 0 plus 2 is now here at 2. When 3 goes in, we get 1. 1 plus 2 is now 3. And when 4 goes in, we get 2. 2 plus 2 is now going to be up here at 4. So there, there, and there. That's all you do. Okay. I'll do B on the same one. Y equals the opposite negative of f of x. So we're going to take this old picture and it's now the opposite, and that's a shift across the x-axis. We're going to flip it down here. In other words, the opposite of -1 is now +1. The opposite of -1 is now here +1. The opposite of this y value, 0, is still 0. The opposite of 1 is now going to be down here at -1. And the opposite of 2 is now going to be down here at -2. So here and there and then there. What is x minus 2 going to do? It's going to move everything to the right 2 units. Everything is going to move to the right 2 units. So when I plug in 0, it's 0 minus 2. 0 minus 2 is -2. And how in the world do I know what's going on at -2? I don't know. I can't graph that one because I don't have the information about -2. 1. 1 minus 2 is -1. I don't know anything about the graph over here at -1. This function is not defined for -1. 3. 3 minus 2 is 1. So when I plug in 3, it is actually doing f of 1. F of 1 is 0. So 3, it's here. It's this point, but it's there. And when I plug in 4, well, I can't even plug in 4. 4 minus 2 is 2, and I don't have a value except maybe it's about a half. That's about all I can do. It's halfway in between. When you think about it, that's a straight segment, so it's up 1 over 2. So this would be up a half and over 1. That is all I really know. Okay. Now, what I could do is this. In order to use 0, I got to plug in 2. 2 minus 2 is 0. So when I plug in 2, I get -1. When I plug in 3, I get what 1 did. When I plug in 4, I would get what 2 would do when I don't have that. When I plug in 5, it's the same as 3. I get 1. And when I plug in 6, 6 minus 2 is 4. I'm going to get the same value as what 4 is. That I can do. But I can't plug these numbers in because it gives me things I can't use. But everything else got shifted over. So x plus 3 is going to move a 3 to the left. This is a non-rigid transformation. All the old y's that we used to get, all the old y's, -1, 0, 1, and 2. Now, when you graph them, they're going to be twice their original value. They're going to be twice their original value. So at 0, the y value is -1, so it's going to be 2 times -1. It's here at -2 instead. When you plug in 1, we get 0. 2 times 0, it's still 0. When we plug in 3, we get a 1. 2 times 1, it's now up here at 2. And when we plug in 4, we used to get 2. It's now 2 times 2, it's up here at 4. And you can see the slopes are much steeper because it's 2 times it instead. And this is going to do what? F of negative x. Flip it across the y-axis from left to right. So that means if I plug in f of 1, I plug in 1, when I actually try to work the function out, it's going to take f of negative 1. So in other words, you have y equals f of negative x. If you try to let x equal just positive 1, when you plug it in, you're actually taking f of negative 1, which we don't know. The only things we know are 0, 1, 3, and 4. So the only thing you can take of, well, 0, f of negative 0 is still f of 0. So when 0 goes in, we still get negative 1. But the only thing you can do now is take a positive 1. To get a positive 1, you would have to let x equal a negative 1. That's the only way to get a positive 1 that we actually know. So now you're actually taking the opposite of the negative 1 that you plugged in. So that y is now f of positive 1 when you plug in negative 1. So we get 0. So at negative 1 for x, we get 0 for y. And then we want positive 3. Well, the only way to get a positive 3 in here is to plug in negative 3. When you plug in 3, we get 1. But now when you plug in negative 3, you're going to get 1. To get 4 and use that y value, we would have to plug in a negative 4. That gives us a positive 4. We got a 2, so when we plug in negative 4, it's going to behave like the right-hand side, and we'll get a positive 2. So it's going to go here, there, and then there. That is now reflected over here. Reflection across the y-axis. And then that last piece, y equals f of 1/2 x. Again, this was a rigid transformation. No. Take away that my graph looks like crap. That is the exact same shape on the left and right hand side. That one, rigid. This one was a non-rigid. Okay, because it stretched it vertically. These first 4 were all rigid transformations. This one, it's something times the x, so it's going to be a non-rigid. Again, the only numbers that we know of, the only things we can plug in and get y is 0, 1, 3, and 4. 0, 1, 3, and a 4. Well, if I plug in 0, it's going to behave like 0. Y equals f of 1/2 0 is f of 0, and we get negative 1. So when you plug 0 in for x, we get negative 1 for y. But when I want to plug in 1 for x, when I want to actually take f of 1, that means I need 1/2 x to equal a 1. What would I actually have to plug in for the x? X would have to be a what? It would have to be a 2. Multiplied by 2. X would have to be a 2. So to get the next possible y value, I would actually have to plug in 2. So y is f of 1/2 times x equals 2. So that's exactly like taking f of 1, which is 0. So when we plug in 2 for x, we get 0 for y, and it's right here. Now we'd like to get 3. That means what we choose for x, we need 1/2 of x to actually equal a 3. So I can plug it in. What is 3/2 of? Anybody? On this side of the room. This side of the room. 3 is half of 2. So when I plug in 6 for x, for the x, y equals 1/2 f of 1/2 times the 6 I'm replacing the x with. That's like taking f of the 3, and f of 3 is 1. So when x is a 6, the y is a 1. So there's 5 and there's 6, we get a 1. The last x value I can plug in is a 4. So that means 1/2 of x needs to be a 4. So 1/2 of what number gives me 4? Half of 8. So y is f of 1/2, x is an 8. That's the same as 1/2 of 8, f of 4. F of 4 is a 2. So when you plug in 8, you get a 2. 4, 5, 6, 7, 8. You get a 2. So it goes here to here, and then from there to there, and then there to there. That's why you're supposed to use straight edge. Right now, I think I can lift straight edge up. But it got stretched horizontal. Because it was a half a minute longer. It took a longer amount of time. It took, let's just say, seconds. It took 8 seconds to complete that graph instead of 4 seconds, twice as much time. If it was 2x instead of a 1/2 x, then instead of taking 4 seconds to complete, I would have been able to draw the graph within 2 seconds time. Because it would happen twice as fast. 19. Remember, the alternative is to say, hey, here's the homework, good luck. I'm trying not to do that. I don't want to do that. Okay. We want to compare 25. I'm going to compare 27. You're doing 25. So 27. All we're doing, y equals x squared minus 2. Compare it with its parent function. You don't have to graph anything. You just need to describe what happened. So let's go to the videotape. There's the parent function. And the x squared is the parabola right here. So if something happened, then A, H, or K needs to have been changed in some way. So x squared minus 2, is that an A, H, or a K that's going on? That's a K, and K equals what? -2. You have y equals A parentheses x minus H squared and then a plus K. So the coefficient in front of the square, that's a 1. 1 times x squared. It's positive, so you know it's going to go up. There's no parentheses, so nobody's messing with the x. H is a 0. And then after the square is a -2, so that must be my plus K. you keep the sign on the K. K is a -2. So compared to the parent graph, this parabola has done what compared to it? Shifted down 2. That's it. Downshifted 2. Okay. 33. Oh, look at that. 33, 31, 31, 33. Yep, but 33 and then 31. My bad. 33, 31. 31, 31. So identify the parent function, describe the transformation shown in the graph, write an equation for the graph function. So you tell me 31 or 33, which one?
31.
31. So the parent function is who? X squared, because it's a parabola. So the parent function is y equals just x squared. Yeah, that's what it was like. And then it's been dropped down. Always double check, because if this was like a 9, then they're counting by 3. If that's a 6, they're counting by 2. They will catch you on that. I will not do that to you, but other people will. So since that's 3 and that's down to -5, they are counted by -1, then 2, then 3. And then just to make sure, it looks like this is going to be 1, and it's not any wider. Not that you could tell. If you had more points, more information, then you could tell if A was bigger than 1 or A was less than 1, wider or narrow. You would have to do that. But with this information, it is just y equals, it's positive because it goes up, positive x squared, and then a -3. That's all. And shift it down to okay. I want to do. I'm going to do, since you got to do 47, I want to show you how to do 47. Sorry, you got to do 49. Since you got to do 49, I'm going to do 47, but I want to show you on the graph and calculator how nice this is if you know what you're doing. Okay. So 47, it says use a graphing utility. So graphing calculator. The graph the 3 functions in the same viewing window. Describe the graphs of G and H relative to the first one, F. So f of x is x to the 3rd minus 3x squared. So the first function, f of x, is x to the 3rd minus 3x to the 2nd. G of x is the original f function, but instead of an x, you're supposed to replace it with an x plus 2. And h of x is equal to 1/2 of the original function, 1/2 of f of x. Now, I know x plus 2, you see a plus 2, so h is the opposite sign. It's a -2. It's this graph, but it's moved 2 to the left. 1/2 means we've shrunken, vertical shrink of 1/2. It's going up half as slow because the a is a 1/2. but you're supposed to grab it with a graphing calculator. So the first one, rather simple, and I don't want this thing going up on me. So we're going to type in x to the third minus 3x squared. Minus 3 x to the second. I'm going to do a basic zoom decimal and see what that looks like. So I'm going to notes a bit. Now, instead of actually to type in the next function, instead of actually having to go x plus 2 to the third minus 3 times x plus 2 squared. Now, granted, you could type it in exactly like that. You could type in, here's your y sub 1 as x to the third minus 3x squared, and your y sub 2, you could just type in parentheses, because you're plugging in x plus 2, you could type in x plus 2 parentheses to the third minus 3 times parentheses x plus 2 squared. You could just do that. You don't actually have to type in or figure out algebraically and simplify. But here's what you can actually do that even is nicer than that. If I go to bars, so right here next to the clear, it says bars. Bar stands for variables. If I click on the bars, now it says bars. Bars or Y bars. I want Y bars. Oh, wait a minute, hang on. Okay. Y bars, and then I clicked on function. So one more time. I went to bars, I went over to Y bars, and then number 1 is function. Y sub 1. This means in my second equation, and I didn't do this, I have to be down here for Y sub 2, my second equation is bars, Y bars, function, Y sub 1. It's going to be the first equation, parentheses. And instead of x, I wanted to use x plus 2. It's going to take the original first equation, but evaluate it instead of x to the third minus 3x squared. It's going to replace on its own x with x plus 2. So it'll graph x plus 2 to the third minus 3x plus 2 to the second. So now when I graph them side by side, and we know that it's supposed to be shifted because it's plus 2, it's going to go 2 to the left. So there's the picture that's 2 to the left. And that means I need to increase my window. So I'm like this. 4. So here's the first one. The original. And here comes the next one. And of course, I'm not happy with the window. Look at that Y. The Y is huge. Okay, there's the original, here it comes out, there we go. And you can see that it's 0, 0 here, now it's over here at -2. Okay, it bottoms out, it reaches like, it looks like a relative minimum here at 2. Now that relative minimum has been shifted 2 to the left, it's over here at 0. The original, its x-intercept is over here at 3, it looks like. Over here, the new one, the x-intercept is 2 to the left, it's here at 1. So it's graphing the f of x plus 2. Now to graph 1/2 the original, yeah, you could just put 1/2 in front of y sub 1. So for my new third equation, I go bars, y bars, function, and the first one, and my bad again, I need to put in insert of 1/2. So it's 1/2 of y sub 1. And that's going to flatten it out. It's going to be a lot wider than the original. Squishy. It's going to be squishy. So I don't have to type in all that stuff or work it out algebraically, then type in all the stuff. It's a nice little shortcut. So that's how you should do 49. And then the last thing we have is 71, 73, 75. 71. The graph of y equals f of x has x-intercept at 2 and at -3. To find the x-intercepts, use the fact. To find the x-intercepts of the given graph, it's not possible to do. At x equals 2, that's an x-intercept. At x equals -3, that's an x-intercept. F of x plus 2. So here's what we know. The original graph of f of x, it crosses the x-axis twice right there. Now that could mean the graph does this. It could mean, it doesn't say that it's a square. It could go like this. It could be a cubic. Don't know what it really does. It could be an x to the 4th. It could, well, that would be 3 right there. It could go like this. Touch it once and then go up. Okay? So there's lots of possibilities. If you have this, and then you decide to move it up 2, so they're now up here. What are the now the x-intercepts? Well, what if it was here and it was a parabola whose bottom was right there? So when you move it up 2, 1, 2, it's now going to be a parabola. Oops. That is now doesn't even have any x-intercepts because it's above the x-axis. So that would be not possible because you don't know what, well, basically you don't know any more about the signs of the rest of the function. You don't know where it's increasing or decreasing. In order to know where that function is going to have its intercepts, you would need to know a vertical shift is going to change the x-intercepts. It's not going to change them uniformly. Now, flip across, that left and right side are now going to be the opposite sides. So on number 69, it's right here and it's right here. Then when you flip across, this 2 now becomes -2, and that -3 now becomes +3. Now you can find it. Because when you flip across, whatever's on the left is now on the right, whatever's on the right is now on the left. You can find it. So it's not noted everything, you just notice certain. If there's a vertical shift, you can't find it. 7.3. Determine which equations may be represented by the graph shown. There may be more than one correct answer. So that is a picture of an absolute value. Absolute values are V-shaped. They're V-shaped. So you see how it's over here in quadrant 1. So the parent graph, f of x is absolute value, just plain old x. Its vertex would be at the origin right there. Because the vertex is in quadrant 1, that means there is an h and there's a k. What h inside the absolute value would have to be x minus an h or x plus an h to move it to the right. Minus, because it went to the right, we do the opposite side. So it would have to be the absolute value of x minus something. And do you see that shifted up? So there'd have to be a plus something afterwards, a positive k. So right here, the first one, +2 would move it to the left. So it's not a. -1. Well, they don't tell us what these units are, so that could be 1 to the right of 2. B is possibility. -2 and up 1. That could work. Is this the same as I go, yeah, x -2 and then a +2? Yeah. You can switch it around. So that's 2 to the right and 2 up. Inside here, parentheses first, x -2 you can't do anything with. So this is just x -2 and then +1. So this is just x -1. On E, it's just absolute value of x -1. Is that enough?
No.
No, because there's no K. There's no vertical shift to make that happen. So this one, they're trying to get you with that +1. That +1 is inside the absolute value. So that's part of the H. This would be the same as f of x equals negative absolute value of x -2 and then a +1 afterwards. So yeah, the x -2 is right. 2 to the right, +1, 1 up, but the negative means it would have gone down instead of up. So it cannot be F either. So the 3 possibilities that would be fine would be B, C, and D. Now, we don't know, you might say, well, this looks further than this looks up. Maybe it's not to scale. It doesn't have to be to scale. So since we don't have anything to compare it with, we don't know exactly where it's at.
Well, the question was just asking, like, in general.
And that's what I mean. But that's why I'm trying to head off that. It looks like because somebody would.
So for those questions, we're just looking for which one it could possibly be. No.
Yeah, and there's more than one correct answer. There may be more than one correct.
Okay.
And then you're doing the same thing on 75. So that means on Thursday, 1/6, 1/7, and let's see how far we get. And if I need, I'm not going to say it right now, but I'll say on Thursday. All right. Let me take a roll. Okay, Josh Aguilar,
Yeah.
Jasmine, Charles, Francisco.
Here.
Lewis. Ryan,
Here.
Marcelino, David, Daniela, that's early. Alyssa Rios, Alma, Ryan, and Kelsey. Okay, have a good day off. I'll see you on Thursday. All right, Lewis, get better.
Thank you.
Welcome.